What makes something a power series? Yes. Okay, it's got x in it now. Okay, so we've x's and n's, which was throwing some of you off before about which one was the variable and how, n goes. Okay, so we're going to talk about power series, which will have both x's and n. N is an independent variable because we don't control n other than where it starts. N just proceeds from 0 or 1 or whatever on through infinity. X we have to control. In order for a power series to converge, that has to be controlled within an interval. All right, so that's two things you got to kind of take away. We can't control n other than where it starts. We can control x using an interval of convergence. All right, so for a power series, you're always going to perform the ratio test. Okay, but the result is not going to be a number. But the result will contain a variable. Okay, so we're not going to get a number like 1/2 or 1/3 or 1/8. We're going to get some kind of expression with x in it. But the rules of the ratio test still apply. Whatever you get needs to be less than 1. Even the variable needs to be less than 1. So you still do the same procedure if you want to force it to converge. Yeah?
So the interval convergence needs to be less than 1?
No, the result that we get, and then we'll find out the interval and convergence after that. If the result was just plain x, if we did the ratio test and the result and all it was x, then yes, x has to be less than or between -1 and 1. Okay, but if the result turns out to be some other expression of x, like 1/2 x plus 4, that has to be less than 1, the whole thing. So the interval of convergence, you might have to do a little more math to it. Okay. In order to force convergence, the result of the ratio test whatever it is containing a variable must be between -1 and 1. Yeah. The result for a power series will not have n in it because when you reduce the ratio, all those n's are going to be gone for a power series. Okay, all the n's will be gone. It's just going to be nice for us because we'll just be left with x's.
So wasn't ratio, if it's converging, didn't it just have to be less than 1?
Yeah.
For ratio test?
For a regular, for a any kind of series that doesn't involve a variable.
Okay.
If you're involving a variable, you have to have, it's the absolute value, so it has to be
Okay.
between -1 and 1. Okay. All right. Oops. All right, once you get this into the following form, it needs to look like this. You need to get down to this point. x minus a is between some number r and some number negative r. You start out with it being between -1 and 1. You'll do some algebra to get it to look like this. We call A the center. We've already talked about that, centered at. We call R the radius. Okay. Then you'll do a little bit more algebra to get x all by itself. What's the only algebra step left? Add a to everything, okay? So to continue, you're going to have -r plus a is less than x, and then capital or positive R plus a. And when you get to that point, this is called the interval of convergence. And so what that will do, it will say the power series that you started with will be forced to converge if and only if x is forced to be constrained between these two numbers. And so you come up with a constraint on x, okay, which will prove, or if x is between here and here, then the original power series will converge. All right, so that's kind of the nutshell of what we're going to do. But then we just got to practice it. Okay, so I'm just going to box this up because, yeah, you can put it in your own words. You can, once you work with it for a little bit, then you maybe want to make a flashcard that makes sense to you. Okay? All right, so let's just try it because I think once we see it, it's a little bit easier. All right, what interval will guarantee convergence for the following power series, where n starts at 0 to infinity, and we've got n x to the n over 10 to the n. All right, we recognize it's a power series just because it's got the variable x. It's a slam dunk for a ratio test for these. Question mark. So we are going to perform the ratio test. Once we've performed the ratio test, we're going to set that up between -1 and 1, and then we'll figure out what interval of convergence would guarantee the overall convergence of the power series. So we'll set up our limit. The ratio test is make everything +1. So n plus 1 x to the n plus 1 over 10 to the n plus 1. Multiplied by the ratio of the other term, so 10 to the n over n times x to the n. And then we simplify. I like to separate my things. You could almost separate the n's, the constants, and the x's if you want to. I'm for sure going to separate my n's, so I'm going to put n plus 1 over n. Okay, I'm going to separate that out. And then I'm going to look at what my other parts are. Yeah.
The bracket.
Oh, yeah. Sorry. Okay, what am I left with? Can you do the reducing pretty quickly? What's left in the numerator? X is left in the numerator, 10 in the denominator. And so n going to infinity, if I divide through by the highest power of n, what's that going to turn out to be? It's going to be 1. Yeah, I mean, if I divide through by the highest power of n, I'm going to get 1. And then the other one doesn't have any n's in it at all. So I'm left with x over 10. Okay, that's the result of the ratio test. You'll always be left with an expression involving x. All the n's should be gone. Okay. The interval that will guarantee convergence needs to start with x minus 10 being bounded between negative 1 and 1. Yes. See what I write, not what I say. Okay. All right, we multiply 10 to both sides. Okay. So now you can tell me where it's centered. Centered at 0, radius of 10, interval of convergence, negative 10 to 10. Now we've got it all. So this interval will force the convergence of the original power series. Any x that I use between those two, now I can't use 10 and I can't use negative 10. It has to be distinctly between. Okay, anything I use between there, back in the original power series, will be a convergent series. Yes?
So usually we will find the convergence, the interval of convergence first, and after that we can find the center?
It's kind of all wrapped in the same process. Like in this one, because it was centered at 0, I didn't have to do any additional math to that because there is no plus or minus here to the x. But this was one and the same with the interval, with the radius of 10, center at 0. Let's try another one. Okay, so same instructions. What interval will force the convergence? So I'm just not going to write the directions every time. Let's just start. Okay, n equals 0 to infinity, from 0 to infinity of x minus 2 to the 3n over 8 to the n. Okay, we recognize it as a power series, so we proceed with the ratio test. All right, I am adding 1 to the n parts, not to the x parts, to the n parts only. Okay, watch carefully how that works with the 3n there. It's not 3n plus 1. Okay, it's x plus 2 times 3 parentheses n plus 1, right? Yeah. Okay, there are parentheses there. Ooh, nope. Okay, over 8 to the n plus 1 times 8 to the n over x minus 2 to the 3n. Okay, I need to simplify that.
That leaves the top as being like, x minus 2 to the 3rd.
Yes. Okay, so when we simplify, maybe we'll write that out a little bit here so we don't make that jump for some people. N minus 2 to the 3n plus 3 is the power on that, over 8 to the n plus 1, and then 8 to the n is the numerator, and x minus 2 to the 3n. Oops. All right, so how many x minus 2's do I have left?
3.
I do, because the 3n, so I've got x minus 2 cubed. And then what about the 8? Okay, over 8. There are no n's left at all. And so the result, since there are no n's, is x minus 2 cubed over 8. Take the result of that ratio test, and I want to force convergence by starting out with it between negative 1 and 1. I multiply everything by 8. And I cube root it. So I get negative 2, x minus 2, and then positive 2. Okay, at this point I can identify the center. The center is not negative 2. The center is 2.
Oh, it's negative.
Okay, so the center is 2. The radius is 2. And so if I have something centered at 2, radius at 2, that will lead to an interval of convergence that has what as its lower bound? 0. And what is its upper bound? 4. And that's your interval of convergence from 0 to 4. Yeah.
When you say radius is 2, do you mean like the ratio is 2?
No, the radius is 2. Okay, so think about a number line. If we go to the number 2, which is our center, and a radius is like an arm that swings out, and that arm will swing out 2 units this way and 2 units that way, giving me an interval from 0 to 4. Okay, it's like a circle radius that swings all the way around.
So it only applies to the x.
Well, applies to the x. Yeah, we're just doing a number line, considering a number line. Okay. Now, additionally, if our x is bounded between 0 and 4, it will force the convergence of the original power series. What will it converge to? That's an interesting question. Okay, look back at it. Okay, what kind of power series is that? It is geometric. And because it is geometric, then this will be forced to the formula for the geometric. And so it will force to the sum, which is a sub 1 over 1 minus r. Okay, the first term of this is 1. What is the multiplier here? Yeah, x minus 2 cubed over 8. So I'm going to clean that up by multiplying everything by 8 because I don't like the way it looks like that. So I'm going to say it's 8 over 8 minus x minus 2 cubed. So this power series will converge to that. In other words, that expression right there would be an approximation of the summation of the power series because it was geometric. Only works if it's geometric.
You're saying there are questions that are not geometric in this?
Correct. One we just had previously was not geometric.
Oh, really?
Again. Okay, let's try another one. It probably will. Yeah, let's see. Let me just, I don't know that I was going to do a couple more, but let me tell you this part. There's a corollary to what we're doing, so we'll just skip our example.
Okay.
Okay. All right, this has to do with the endpoints. So what happens, like if it was equal to 4, or what happens if it's equal to 0. So you're just going to have to press pause on that. We will deal with the endpoint test next week. Okay, so how to handle endpoints. However, let me talk with you about the corollary to the ratio test. What if you get 0? Like you do the ratio test here, and what if you get 0? That means something special. A ratio test result of 0 means total convergence. That means you don't have to limit it to an interval of convergence. It means it converges for all real numbers. That there is no interval of convergence. It converges everywhere. Okay? The opposite is true, which would be a ratio test. What's the opposite of 0? Okay, a ratio test of infinity would mean total divergence. That there is, the only place it would converge would be at its center, but nowhere else. Okay? All right, that was the last thing I wanted.